course. Today we are going to learn on how to locate and correct error. And I will look on our work on June, July 24, Module 3 Mathematics in Electrical, Diploma in Electrical and Electronics Engineering. The table, the polynomial. And now use table of finite difference to locate and correct error. This is how we go about it. For us to create the finite table, I've created already, but we can look on it briefly. We can work on it briefly. So, first to create the finite table, as long as we are told we are taking polynomial, so we are that for the difference. So, this is how we go about it. First, to get the first four difference, we subtract 2 from 7, which is 7 minus 2. We get 5. 5 minus 7, we get minus 2. 5 minus 5, we get 0. 10 minus 5, we get 5. 27 minus 9, we get 17. 62 minus 27, we get that 5. 121 minus 62, we get 59. Again, for us to get the second 4 difference, minus 2 minus 5, we get minus 7. 0 minus 2, we get positive 2. 5 minus 0, we get 5. 17 minus 5, we get 12. 35 minus 17, we get 18. 59 minus 35, we get 24. 2 minus 7, we get 9. 5 minus 2, we get 3. 12 minus 5, we get 7. 18 minus 12, we get 6. 24 minus 8, we get 6. That's how we create the table. Now we want to locate the correct error. I would like to show you the simplest way or the simplest formula of how you can locate and correct your error. Now, for us to locate the error, we have to find the average. We have to find the average of the values under the third for difference, which is 9 plus 3 plus 7 plus 6 plus 6. And we get the value of that one. If we divide that one by the number, which is 1, 2, 3, 4, 5, divide by 5, we get 6.2. 6 approximately, this is approximately 6. Back to your table that you have created, you check another for difference. This lies between two numbers, which is 6 and 6, and the others are we have 3, 9, and 7. This means that 3, 7, and 9, we have an error. This means that now our error started going easy. This means these numbers are correct. We have no error. So our error is between 2, 7, and 5. 2, 7, and 5. Now, you just say these numbers must be 6. Just assume these numbers must be 6. And it's true, they must be 6. So you ask yourself, which number, if we subtract from 12, we get 6. The number is 6. 12 minus 6, we get 6. Which number, if we subtract from 6, we get 6. The number is 0. 6 minus 0, we get 6. Which number, if we subtract from 0, we get 6. The number is minus 6. So 0 minus 6, we get positive 6. Again, you ask yourself from this and now this 5. Which number, if we subtract from 5, we get 6? Which number, if we subtract from 12, we get 6? The number is minus 1. 5 minus 1 is equals to 6. Which number, if we subtract from minus 1, we get 0? The number is minus 1. Minus 1, minus 1, we get minus 1 plus 1, which is 0. Which number if we subtract from 0, from minus 1, we get minus 6, and it is 5. Minus 1, minus 5, we get, minus 1, minus 5, we get 6. So this means this number is correct. So again, we have on this 5. Which number if we subtract from 5, we get minus 1, and the number is 6. 5 minus 6 is minus 1. which number, if we subtract from 6, we get -1, and the number is 7. 6 minus 7 is -1. So this means that our error was from 5. It started from 5. So this means that we have located our error. Our error started from 5, and already we have corrected our error. We have corrected our error, and we say that our error now 6 is the actual number, which is accurate number. 6 is our accurate number. They have the formula that we want to see the error, we want to see the value of error. So we see this alpha. The alpha is this number, which is with the number with error minus error. We get the actual number, which is 6. Actual number. So 5 is alpha, the number with error, minus error is equals to the actual number, which is now 6. So minus negative error is equals to 6 minus 5. This means minus error is equals to -1. Not -1, but it is +1. So error is equals to -1. So our error is equals to -1. This is how we locate error in simplest way, and now we correct that error. So this table is now corrected. The actual number is 6, and the error is from 5. Spreading. This means error spreading that way. So these numbers in between these lines means that they will be having an error. And if we proceed, even then they have an error. But the numbers in the for difference or in polynomial will be zeros. So now we have created a finite table. We have used that finite table to locate the error, and now we have corrected the error. Thank you. You can try another. This is another example. But the series is different. Again, the third polynomial. So they were told to create a table, a finite table to locate and correct error. But that's why we have created up to that one difference. Again, you know how to create the table. I will not repeat on how to create the table. I have created the table the values of x were -1 to 5. The values of x were 4, 2, 0, 5, 20, 54, and 1, 12. Now, we are going to use finite table to locate and correct error. As you know, we have the formula of correcting error. We see that alpha, which is the number with error, minus error, we get the actual number. Now, and again, there's another formula. We see that average plus error is equals to just number below is equals to the number below. If it is a 7, we have the number below. If here we have 6 or whatever, this number. So the number below. So average plus error is equal to number below. So I will show how to work with this formula. This is number below. Now let's work on this. First of all, let us find the average. The average of the third four difference values. 7 plus 3 plus 9 plus 5. We get 24. Again, 24 divided by the number, which is 1, 2, 3, 4. Divided by 4, we get 6. This is now our average. As you can see, we don't have the 6 in our than four difference. So what did we do? This means that these numbers have errors. So the number up and the number down here means that they contain 6. So our error is between this bracket. So this is where we have our error. So it means now again the 5 is the number with error. We have located our error, which is 5. And we have said that alpha minus error is equal to actual number. So an average plus error is just the number below. So let's assume you have 86, of which you 86. So this is the average, which is 6 plus error is equal to the number below, which is 7. Now our error is equal to 7 minus 6. So our error is equal to positive 1. So again, apply this formula. Alpha minus error is equal to actual number. So that alpha, which is 5, minus error, which is 1, is equal to actual number. And the actual number is 4. Actual number is 4. So this is the actual number. So here we have 4. Let's use the formula that I've taught you in the previous example. We have 6 as the average. Let's assume these numbers are all 6. They were supposed to be 6. Let's assume they were supposed to be 6. Or they must be 6 for the table to be correct without an error. So which number, ask yourself, which number, if we subtract from 24, we get 6. And the number is 18. This is the correct number. So again, which number, if we subtract from 18, we get 6. The number is 12. So 18 minus 12 is 6. Again, which number, if we subtract from 12, we get 6. And the number is 6. 12 minus 6 is 6. Which number, if we subtract from 6, we get 6. The number is, if we subtract from that 4, we get 18. And the number is 16. That 4 minus 16 is 18. Which number, if we subtract from 16, we get 12? We get 12. The number 16. The number is 4. 4 minus 2, we get 6. We have corrected that column. Now, which number, if we subtract from 20, we get 16. The number is 4. This means this is the actual number. 4. 4 minus 0 is 4. And we have located our error, and we have corrected the error. The same answer, we apply this formula. These formulas are suitable for that question. So you will choose which one to use. But thank you for watching. And let's continue subscribing, sharing, commenting, and requesting for